we have that R success. Boom. And what's the probability of having a success on any trial is just P. Notice this is for all values of R of Y equal to R plus 1, and so forth. Again, you have to have a minimum number of trials that the minimum would be R. If you want 5 successes, you have to have at least 5 trials. You could have 6 trials, you could have 7 trials, so forth like this, but the smallest that your random variable could be is exactly how many successes you're looking for. The mean of this distribution, again, not going through the proofs of these things, but you could do it. You could show it, mathematically prove it if you wanted to endeavor on that. Mean of this distribution, a negative binomial in the general form, is R divided by P. And the variance is, as you see, R times 1 minus P divided by P squared. So that gives you, that is another common distribution that comes up. Let's look at an example of this. The employees of a firm that manufactures insulation are being tested for indication of asbestos in their lungs. The firm is asked to send 3 employees who have positive indications of asbestos onto the medical center for further testing. If 40% of the employees have positive indications of asbestos in their lungs, find the probability that 10 employees must be tested to find 3 positives. Okay, so note that the probability of an employee having positive indications of asbestos in their lungs stays constant. That's a 40%. Maybe this is a company that's been in existence for 50 years, and they've gone through all the health records of all those employees. It's a fairly constant number. 40% is what they've determined. Now, you're interested in sending, the firm is asked to send 3 employees who have positive indications of asbestos onto the medical center. So they have to find 3 employees to send. So they'll keep testing until they find those 3 positives. What's the probability that they test exactly 10 employees, and on that 10th trial, they find their 3rd person that they're going to send on to the medical center? So what we're looking for, just kind of plugging into the previous slide formula, we have Y, probability that Y is equal to 10 trials. We're interested in finding 3 successes. In this case, kind of a gross thing, but a success is defined as somebody with indication of asbestos in their lungs. Okay, so what we need is on the 9 trials, first 9 trials, we need to have 2 successes, 2 people. And so how do we figure that out? That's that first block here of 10 minus 1, choose 3 minus 1. 9, in the first 9 trials, find 2 people. All sorts of different ways, again, you could do that. You could find, boom, back to back, 2 people with asbestos in their lungs on the first 2 trials. You take 2 employees and boom, there they are. They have asbestos in their lungs. But the question is 10 tests, 10 trials to get that 3rd employee. So even if you get them straight out of the blocks, the first 2, you still are assuming you're going to go through 7 more to get 9 trials total, where you only found 2 people with asbestos in their lungs. And then on that 10th trial, you get the 3rd person. So 9 choose 2. Again, multiplying that against the P to the 3 minus 1 rather, and because we have 2 people in the first 9 who do have it, so probability of success P that they have it, and probability of success 1 minus P to the 10 minus 3 or 7. So you've got that 9, and what you're saying is you've got 2 successes in the 9, therefore you've got to have the other 7 being the failures, so to speak, or the people that don't have asbestos in their lungs. And then on that 10th trial, boom, you have that last person, the 3rd person, with probability P that they have asbestos indication in their lungs. So cranking through the formula, you end up with a probability of 0.0645, not a very large probability to go through to get that you would have that 3rd person identified after 10 trials. Okay, extending that same example, suppose each test costs $20 and you're looking at the budget. You're the company that has to have a budget set aside to do these tests on your employees to meet whoever's dictating you must send 3 employees. So you might want to look at what are your expected value and the variance of the total cost of conducting these tests. Well, again, the mean of your negative binomial distribution is R over P. So E of Y would be 7.5. And again, just comment on this, 7.5 tests, what does that mean? You either have 7 tests or 8 tests. But again, the long run average is not meant to say, here's the exact number that you're going to have. It's a mathematical computation that says on average, you're going to have 7.5 tests. People understand that, just understand that that's mathematical computation and it can turn out to be fractional. Variance of that random variable for the number of tests that you conduct, just plugging in, what is the variance of a negative binomial distribution? R times 1 minus P over P squared gets you 11.25. So as we recall that for a linear function of a random variable, the second part of the question is to say, if we say C is the total cost, and we identified that C is $20 per test, so 20y is our function, what is the expected value of g of x, or the linear function in this case, of C? That's just going to be 20 times the expected value of y, or 20 times 20 times 7.5, or $150. The variance associated with the cost, recall that the variance associated with the linear function ax plus b would be a squared times the variance of the random variable. So here we have a would be 20, so we're saying the variance of the cost is equal to 20 squared times the variance of y. So it ends up being $4,500. Should have some dollar signs in front of that. Okay, so some additional, going even further with this example. So each test costs $20. Try to pull all these things together, because one of the things you know with probability and statistics is it definitely does build. Your knowledge of one thing leads you to the knowledge of understanding of, and working with it on other things. So we're going to look at Chevy test and how it might be of interest here. If each test costs $20, it is highly likely that the cost of completing the test will exceed $350? So there we say, okay, well, let's think about Chevy test. How many standard deviations? So we found that the expected value of the cost of running the test would be $150. The variance of the cost would be $4,500. So we want to know how likely. Is it really likely? Is it 90% chance? Is it 10% chance? What is it? How likely is it that the total cost would exceed $350? And you can imagine as a manager and somebody trying to figure out, imagine it's not just $20, it's $2,000 per test. So you could be talking about a big budget. But let's say it's $20 in this case. So how many standard deviations is $350 from the cost average, the expected value of the cost of $150? Well, again, we're missing the parentheses around the 350. The parentheses are wrong here. 350 minus mu, and that's where the parentheses should be, divided by the standard deviation would tell us how many standard deviations away 350 is from the mean. So 350 minus 150, take that difference, 200, divide that by the square root of 4,500, and we end up with, it's about 3 standard deviations away from the mean, above the mean, of course. And so if we say letting k equal to 2.98, then Chevy test gives us that the interval, the mean minus 2.98 times the standard deviation, that's the lower side of Chevy test. The upper side of the interval would be the mean plus 2.98 standard deviations. And so we have the cost running between minus 49.9, let's say, dollars, up to 350. Must contain at least 1 minus 1 over k squared, or 88%, 89% of the 0.89 probability associated with it. Since the daily cost cannot be negative, at most 0.1126 of the probability mass can exceed $350. Thus, the cost cannot exceed $350 more than 12% of the time. Again, what are you doing? So you're saying that Chevy-Chase says that between 0, forget the negative 49. So with probability at least 0.8874, let's say, the probability will be at least that the random variable will between the random variable C in this case, the cost will be between 0 and $350. That's Chevy-Chase. The probability that their cost will be between 0 and $350 will be at least 0.8874. So what does that mean? The probability 1 minus that gives us the probability that the cost turns out to be greater than 350. And that's where the 0.1126 comes from. Okay. So that gives you kind of an extension of that example right into some of the Chevy-Chase. Again, we will go through some of these examples. We should have, by this point, already have spent some time doing some examples and exercises on Chevy-Chase to give you a flavor that this is just applying it some more. As I've done in the previous example, common distributions, a few additional practical things that have been published about, where people made a mapping and said, okay, here's my true study or true analysis I needed to do. And when they looked into it, indeed, it can come out to, be a negative binomial. Okay, learning checkpoint. A large lot of tires contains 10% defectives. 3 tires are chosen from a lot and placed on an F-35. Find the probability at least 6 tires must be selected from the lot to get 3 good ones. Find the expected value and the variance of the number of selections that must be made to get 3 good ones. Okay, so that's a brief look at the negative binomial distribution function, one that is fairly common. And I'm going to go ahead and stop the recording at this point, and we'll resume next with the Poisson distribution.